Now on this video we will review over the basics of writing chemical formulas, and you will need to have your chart of polyatomic ions out in front of you, and you will need to have your periodic table out in front of you in order to do these problems. Now, as a review of your periodic table, you should have your ion charges written at the top of each group on the periodic table, and if you do not, you need to take a moment and do so. Now, your group 1 elements will have a +1 charge, your group 2 will have a +2 charge, your transitionals will have a +1, 2, or 3 depending upon the chemical formula, and we'll discuss that a little bit later. Your group 13 would have a +3. Right here we would have a plus or -4, -3, -2, -1, and 0. Now, if you have forgotten your chart of polyatomic ions, I did put this one in for you that you can refer back to as you need to. Now, I am going to go through this from memory, so if you're wondering where I got the formulas on these upcoming problems or where I got the charges, come back to this chart and you'll find that information on this chart. We are going to begin with binary ionic compounds. Now, binary ionic compounds are compounds that are made up of two different elements. One's a metal and one is a nonmetal. And to write our binary formulas, we're going to write our cation first and then our anion. So our positively charged element will go first, our negatively charged element will go second. Now we need to look up their charges from the periodic table. Calcium has a +2 charge. Chlorine has a -1 charge. You can go back 2 slides and look at my periodic table to see that. We're going to ignore the plus and the minus. Now, a well-written, correctly written chemical formula, our elements' charges together will equal a 0 charge, making it non-active, just like a noble gas. So in essence, what we're doing is we're asking how many +2 calciums and how many -1 chlorines must come together to equal a 0 charge. And the simplest way to do this is to crisscross our charges. So we bring our 2 over here and our 1 over here. What that means is that 1 calcium with a +2 charge, 1 times +2 is a +2, 2 chlorines, each with a -1 charge. 2 times -1 is -2, plus 2 plus a -2 equals a 0 charge. So we're canceling out our charges. What you need to know is that we're going to crisscross. Now let's look at another example here. Here we have sodium and we have chlorine. We write sodium first, it is our cation. We write chlorine second, it is our anion. Sodium has a +1, chlorine has a -1. We will ignore the plus and the minus. Now we'll take this one, crisscross it here, take this one, crisscross it here. So we would get Na1Cl1. We do not need to write the ones, so we would get NaCl. Alright, let's look at another example. Here we have potassium sulfide. Now potassium is K with a +1 charge. Sulfide is sulfur from the periodic table. It has a -2 charge. So we write it K +1, S -2. We are going to ignore the plus and the minus, and we're going to crisscross those charges over. When we crisscross those charges over, we get the K2S. Now this is showing you exactly what we were talking about on that previous slide of canceling out to get that 0 charge. However, in writing out our formula, this is what we're looking for. What about those transitional elements? Well, if we look at iron Roman numeral 3 chloride, the charge of the iron is given to us in our problem, so that we know iron has a +3 charge. Now chloride is chlorine from the periodic table. It has a -1 charge. Again, we're going to ignore the plus and the minus, and we're going to crisscross our charges over. When we do so, we get FeCl3. Now here we have some example problems for us to work through. I've gone through and have written out some of this information in advance, but let's go through these. Number one, write out the chemical formula for sodium chloride. Well, sodium is Na with a +1 charge. Chlorine is chloride with a -1. We're going to crisscross our charges, and so our answer we would come up as Na1Cl1 or NaCl. Now when we get to binary covalent compounds, that's compounds right here that contain those prefixes. We do not need to crisscross. So we know that nitrogen is N, dinitrogen means 2, we have oxygen, and pent means 5. So we would have N2O5 and no need to crisscross. Now oxygen itself, if we're looking at oxygen, if it's diatomic, we're going to have oxygen with a -2 charge. Potassium is potassium with a +1. We look on our Fat Daddy chart, or our previous chart, and that's sulfate. It's SO4 with a -2. Now we're going to crisscross our charges. This is important for you to know. We will write K. Now anything that we pull off of that chart that is polyatomic, such as SO4, we need to write that in parentheses because we do not want to drop that 4. Now we're going to bring that 1 over to here, and we're going to bring that 2 over here. And so we would end up with K2 parentheses SO4 close parentheses 1. We can drop that 1, so we would get the answer K2SO4. Now here we have sulfurous acid. Now if we look at sulfurous acid, we go back to our previous video, that would be a sulfite ending, and so it begins with H because it's an acid. Sulfite was SO3. Hydrogen has a +1 that we're going to bring over, so if we're going to bring that over, we've got to put parentheses around there. And sulfite has a -2, so we'll bring that over, and we get H2 parentheses SO3 close parentheses. Now technically you can write this as H2SO3, but when you're learning to write these out, I encourage you to go ahead and use those parentheses just so that you keep the SO3 written intact. Silver acetate. Silver has a +1. Acetate from our chart is C2H3O2. We're going to crisscross our charges over, and so we get Ag C2H3O2. If you feel better putting that in parentheses, go ahead and do so. There's nothing wrong with that, and you'll make sure and have it written correctly. Number 7, we have chromium 3 nitrate. Chromium has a 3 charge, and we see that from our problem. Nitrate from our chart is NO3 with a -1 charge. We're going to crisscross our charges. We would get Cr1. We're going to write parentheses NO3 close parentheses, and you saw that we brought that 3 over right here, so we'll put that 3 right there. Sulfur trioxide. Well, we're using those prefixes again. This must be a binary covalent compound where we have 2 nonmetals. So we write our S for sulfur, and then we got our oxygen, and we had that prefix for 3, so that's an SO3. Number 9, we have ammonium carbonate. Ammonium is written as NH4 with a +1 charge. Carbonate is a CO3 with a -2 charge. We're going to crisscross these charges over. Remember, we're dropping the plus and the negative, so we get our NH4 parentheses, we brought that 2 over, and then parentheses CO3 close parentheses, and we'd have that 1, and we do not need to write the 1. Here we have calcium hydroxide. Calcium with a +2, hydroxide has a -1. We're going to crisscross those charges over. We get Ca parentheses OH close parentheses 2. Now lithium has a +1 charge. Sulfide is sulfur from the periodic table. It has a -2. We're going to bring that 1 over, bring the 2 over, and we would get Li2S. Phosphorus acid. Now we go back to that. It's an acid. It begins with H. Phosphorus indicates that it's a phosphite. So that's going to be a PO3. It has a -2 charge. And we're going to bring that right over, crisscross, we get H2PO3. Now if you have any additional questions, by all means come by my classroom for additional help.